Some time ago, an image recorded in the regions representing the beginning of the universe, captured by the James Webb Space Telescope, left the scientific community intrigued. A bright red point, far from everything. After careful analysis, the point was a supermassive black hole. This was strange because there didn't seem to be enough time for it to accumulate so much matter to become supermassive, as there wasn't enough time for enough stars to reach the end of their lives and form black holes as immense as these. Because of this, several hypotheses arose to try to explain the presence of these objects in such a young epoch of the universe, some suggesting that they are consequences of disturbance in space-time itself. Something similar to a rug being shaken with great force due to the acceleration of the universe's expansion, sudden and greater, at that time. Other hypotheses pointed to the possibility of things still unknown to us that were only possible to happen at that time due to the beginning of the great faster expansion influenced by dark energy. In addition to this strange discovery, that generated quite bizarre hypotheses, other observations are revealing different characteristics than what was expected. Now scientists are publishing articles trying to better understand how these things were possible and to understand how the universe was in its beginning. Finding images of supermassive black holes was the first shock. Analysis of Webb's data suggests that black holes not only existed at the beginning of the universe, but also played a fundamental role in the formation of stars and galaxies, suggesting that they were present since the early stages of the universe and may have accelerated star formation. Data observed by Webb shows distant galaxies from the primordial universe that are brighter than expected, with a large number of young stars and supermassive black holes. This suggests that black holes actively influenced the environment around them, transforming gas clouds into stars quite rapidly. According to British astronomer Joseph Silk, the lead author of the study, black holes may have released compressed gas clouds, stimulating star formation. This process may explain why primordial galaxies are brighter than predicted, as the rate of star formation may have been driven by these primordial black holes. According to him, the universe went through two distinct phases.
In the first, black holes accelerated star formation, and later emissions of material from these black holes decreased and star formation slowed down. This process resulted in rapid star formation, followed by a gradual decrease over time.
At the center of many galaxies, including our Milky Way, there are supermassive black holes, with masses millions or even billions of times larger than the Sun. Currently, we do not know how they reached such immense sizes, as between stellar black holes and these supermassive ones, there is a size scale that we have never observed anywhere else. What we see are reasonably small black holes, and then the gigantic ones. This shouldn't be the case, as the way we understand this growth is through the collision of several other smaller black holes, which over time end up at the center of galaxies. So we should observe these objects of various sizes throughout the universe, which doesn't happen. Besides this detail, a new analysis suggests that black holes not only formed before stars, but also before galaxies. This suggests that black holes and galaxies coexisted and influenced each other's fate during the first 100 million years. If the entire history of the universe were a 12-month calendar, these years would be like the early days of January, which is quite early in the age of the universe, even for galaxy formation. Previously, it was believed that such massive galaxies could not exist so early in the universe, as there wasn't enough matter and concentration to form such clusters. However, Webb's observations revealed two galaxies that existed about 350 to 450 million years after the Big Bang, much earlier than anticipated. One hypothesis is that some stars may have begun to form earlier than thought, perhaps as early as 100 million years after the Big Bang. The characteristics of these galaxies, such as being extremely luminous and having spherical or disk shapes instead of large spirals, are also peculiar to scientists. They are extremely large, indicating that they formed more rapidly than current models predicted. Their extremely high luminosity suggests that they may contain supermassive black holes or very high rates of star formation, both conditions contradicting what was believed to be seen in this early stage of the universe. Additionally, they may signify that the universe's reionization process occurred differently than previously thought. Reionization occurred shortly after the period known as the Dark Ages, when the universe was dark and filled with hydrogen. Reionization marked the time when the first stars and galaxies began to form and emit enough light and radiation to ionize hydrogen. Scientists believe this occurred approximately between 150 million to 1 billion years after the Big Bang, where reionization transformed the universe from an opaque and dark state to an illuminated and transparent state, allowing light to freely travel through space. However, the maturity of these galaxies implies that this evolution may have started much earlier and occurred faster than theories suggest. The fact that they are premature, existing in an advanced state of involvement in such a young universe, raises questions about how quickly matter can clump together and form such complex structures. To further complicate matters, a study from the National Astronomical Observatory of the Chinese Academy of Sciences even suggested that the universe may be younger than the current estimate of 13.8 billion years. On the other hand, there are also other researches that go against this. For example, astronomers from the Atacama Cosmology Telescope, located in Chile, conducted new observations and, applying a bit of cosmic geometry, arrived at the result of 13.77 billion years, with a margin of error of 40 million years plus or minus, which corresponds to the estimate provided by the Standard Model. Observed by Webb, galaxy JWST 7329 surprises with its size and age. It is 4 times larger than the Milky Way and emerged approximately 11.5 billion years ago. This galaxy contains even older stars, about 13 billion years old. This means that it formed only 700 million years after the Big Bang, which also challenges the view we had about it. The current view on galaxy formation suggests that massive galaxies like JWST 7329 should not be possible in the early millions of years of the universe, as there wasn't enough matter in concentration to form such stellar clusters. The discovery of this galaxy in a state that scientists call quiescent is at the very least curious. When a galaxy is described as quiescent, it means it is in a state of inactivity, meaning it is not forming new stars and has little or no star formation activity. Quiescent galaxies are generally older and contain stars that have already evolved to later stages of their life cycle. Thus, finding a galaxy in this state alongside active galaxies, which are rich in gas and continue to form new stars in the early universe, is quite surprising, as it challenges previous theories about how quickly galaxies can deplete their gas and shut off star formation. This raises questions about how galaxies can form so rapidly, and what leads them to abruptly cease star formation while the rest of the universe continues alive in this same process. Since this galaxy is too opaque to be studied by ground-based telescopes, Webb's observation has become even more crucial in understanding these massive and quiescent monsters that, hidden from our eyes, inhabit the deepest regions of the universe.